Happy Monday. We're going to go over the Apache web server security checks, the Apache HTTP web server, which is a highly used web server. Great traction, great open source, been around for ever. So if you look at the slide, Apache web server security view, we're going to go over the NIST, the FIPS 140-2. I call it the blue team because we're going to lock down the server, make sure nobody can hack it, and we're going to actually do the DISA STIG checks to actually lock down the server. Once again, we're going to actually walk through the AWS implementation where you would actually put that on a network. It should be super short too. Once again, everything will be in the description box. It's not many security checks actually for Apache. They did a great job locking it down for themselves. So I'll put all the security checks in the description box. So once again, where already talks about the AWS networking. So if you look at the diagram right here, we're going to put the web server. So this is going to be in the DMZ. This is the user. So the first thing it can touch will be the web server applications. So that's going to actually be in the public segment of the network, standard 3-tier network. The web server will actually go into the public part of the network and will be publicly accessible, making that's going to be the first place the red team or the hackers would actually attack or get to. So another representation, this is the web server right there. So this is the end user. It's going to go through our load balancer /WAF, get to the web server. The web server will be accessible to the public. This will be our DMZ. The web server will be access to the public network, and this will be the private part down there. So once again, we talked about the WAF. AWS WAF application, HTTP security server. So part of the security assessment is we want the WAF load balancer actually in front of the web server. The WAF is a web application and firewall that helps protect your web application servers or API against common web exploits that may affect availability, compromise security, or consume excessive resource. The AWS WAF web application firewall gives you control over how the traffic reaches your application by enabling you to create security rules that block common attack patterns, such as SQL injection or cross-site scripting, and rules filters out specific traffic patterns you define. You can get started quickly by using Manage Rules by AWS WAF, a pre-configured set of rules managed by AWS or AWS Marketplace sellers. The managed rules for the WAF addresses issues like the OWASP top 10 security risk. If you look in my videos, I did a video on the OWASP top 10. The rules are regularly updated as new issues emerge. The WAF includes full feature API that you can use to automate the creation, deployment, and maintenance of security rules. So we're talking about protecting the HTTP security server. The first way you would do that is the AWS WAF web application firewall. There's actually open source web. Apache has its own called security mods you can actually put in the front. So these are some of the things that blocks out: allow list, deny list, SQL injection, cross-site scripting, HTTP flood. You can block scanners and probes, IP reputational lists, and bad bots. So those are all the things you can block out with a web application firewall, being on-prem or in cloud. So Apache HTTP web server is a project is collaboration of software development effort aimed at creating a robust commercial-grade, feature-full, and freely available source code implements of an HTTP web server. The project is jointly managed by a group of volunteers located around the world using the internet and the web to communicate, plan, and deploy a server and its related documentation. So once again, this is an open source product, widely known, Apache HTTP server. So once again, doing a Beanstalk is a application development. As part of that, the Apache web server is built in. AWS Elastic Beanstalk is an easy-to-use service for deploying and scaling web application and service deployed with Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker on a familiar basis. Familiar servers such as what we're going to talk about today is Apache, Nginx, Passenger, and IIS. So once again, this is open source development. Apache is included in Beanstalk, and it will come pre-configured and get your development environment set up super quick. So let's get to the security checks for Apache. So this is the first one. We got probably the top 10 we're going to go over. Once again, I'll have all of those in the description box. So the first Apache security check is vulnerability 92761. It's medium. The Apache web server must perform server-side session management. So when a user logs on, so you can keep track of them, it creates a session key. And that session key, when you log on, it keeps track of what you look at, saving your credit card so you can bring back the proper session information. The Apache server must use an encryption strength in accordance with the categorization of data hosted by the Apache web server where remote connections are provided. So if you remember at the beginning, we talked about FIPS 142. That's government grade encryption, and that's what we're trying to do. My site is usually for federal compliance. So we're going to talk about the commercial grade of encryption, which is FIPS 140-2. The Apache server must produce log records containing sufficient information to establish what types of events occurred. So every time you log on the server, if you were denied, password denied, what URLs you went to, what part of the web server you went through. So if we got hacked, we'd be able to go to the logs and figure out what happened to our server, who did it, and hopefully what they stole, how big a file we went out. The actual log should show the size of the payload and the API of the payload. So those are the things we want to properly log in case we need to do forensics on our website. The Apache web server must not perform user management for hosted applications. So what that means is, since you can have multiple web servers or multiple applications in Apache, you don't want the Apache doing that. You want that technology built into each website that's on the Apache server. The Apache web server must have multiple-purpose Internet Mail Extension MIME that invokes operating system shells disabled. So since you shouldn't run a mail server and your application server actually on the same website. So if you're running this as a website, you want to cut off your internet mail. The reason doing that, a lot of malware is sent through email, a lot of hacking is done through email. So you actually want to cut that off and block those type of traffic on your web server. If we do the proper checks that were located on here, we're going to comply with these. We call them GRCs, governance, risk, and compliance. So if we do the proper checks, we can qualify to do HIPAA, which is health, PCI, which is credit card, FISMA, which is government regulations, FedRAMP is government regulations in the CAL, and publication IRS 1070 means we can accept tax information from the federal government. So those are some of the compliance you can qualify for if you do the proper checks. Once again, that's GRC, governance, risk, and compliance. We're kind of focusing on the compliance piece today. And once again, it's a short video. I'll put all the checks actually in the description. We went over the Apache security server review checks for NIST 800-53. The encryption we were going to use was FIPS 140-2. The blue team, we're going to lock down our server, hopefully block the red team and any hackers. We went over the STIG checks. We went through the Amazon networking. Elastic Beanstalk is Amazon version of the Apache server, HTTPD. Once again, it's Professor Black Ops, Cybersecurity for the People. Please subscribe. Thank you very much.